Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram. Welcome to the online lecture series. This lecture we will discuss about the concept of convolution in time domain by using graphical representation. This class we will discuss about the concept of convolution in time domain in graphical representation. The convolution, first we will try to understand the convolution concept in discrete time, then later we can extend the same concept for continuous time signals. Y of n is nothing but x of n. Convolution session we have seen the convolution property. It's a commutative h of n convolution with x of n. Both leads to the same. Steps involved in convolution. First step is folding. Second step is shifting. Third step is multiplication. Addition. Write the equation for y of n. Y of n is equal to summation x of k h of n minus k. K is equal to minus infinity to plus infinity. Because convolution is commutative, this can also be written as h of k and x of n minus k. K is equal to minus infinity to plus infinity. So depends upon our convenience, we can keep one sequence constant. Second sequence we have to take the mirror image or fold that signal or mirror image. So first we have to keep one sequence constant, that is either x of k or h of k, depends upon our convenience. Second signal we have to take the mirror image, that is h of minus k in this case, and this is x of minus k in this case. Then we have to shift this sequence. This is h of n minus k for all values of n. This is x of n minus k for all values of n. Then we have to multiply this with x of k into h of n minus k. And similarly here, this should be multiplied with h of k and x of n minus k. And final step is we have to add. We have to add for all values of k, minus infinity to plus infinity. Similarly, this is for minus infinity to plus infinity. This is nothing but your final output y of n. Convolution involves 4 steps. First step is folding of one signal or taking the mirror image. Second is shifting. Third one is multiplication. Fourth one is addition. Depends upon your convenience, you can keep one sequence constant. Second sequence you have to take the mirror image and you have to shift that sequence. Then you have to multiply. Then finally you have to add to get the final output y of n. Previous session we have solved one problem on convolution, a simple finite duration sequence 1, 1, 1, 1, and the h of n is 1, 1, 1, and you have to calculate y of n. This is nothing but x of n convolution with h of n. Okay, and this will be equal to, according to the commutative property, h of n convolution with x of n. Nothing but summation. This is x of k of n minus k, and here the k is equal to. So for infinite duration sequence, I will explain the convolution concept step by step. For whenever the finite duration sequence given, we have to make use of this shortcut. Write all the sample values of x of n here and all the sample values of y of n here. This is these samples are h of n and these samples are x of n. So multiply all the samples of h of n with first sample, that is 1, 1, 1. Similarly, multiply this with all these values 1, 1, 1, then 1, then 1, 1, 1. So final output from this is you have to add all these values. So diagonally this is 1 and this is second sample and this is third sample, this is fifth sample. First sample will be 1. Second sample will be this 1 plus 1. So this is, and third sample is this plus this plus this, that is 3. And fourth sample is this plus this plus this, and again 3. And fifth sample is this plus this, this is 2. And last sample is this one. And this is the final output for the previous problem. You can make use of this. Now the same convolution concept we can extend for infinite duration sequence. So let me take an example. X of n is equal to u of n and h of n is equal to a power n u of n, and you are asked to calculate y of n. Okay. Then we have to plot this sequence. X of n is u of n. U of n is nothing but unit step function, and so on. 1, 2, this is. So here, whenever h of n is having this type of problem, so we will be given a power n. A value you have to take in between 0 to, otherwise they will give. So if you try to plot this h of n also, a equal to, suppose you take half, this value is 1, as n increases, this value is keep on decreasing. 1, 2, 3, 7. So exponentially decreasing function. And this is n, and this is 1. And from this, what you have to do is you have to calculate y of n, which will be equal to x of k into h of n minus k, and sum over k is equal to minus infinity. So first you have to calculate x of k. Now you try to draw x of k. That means the same signal, just a simple notation change. 1, 2, 3, and so on. This is x of k. Now h of k, so keep on decreasing this one, something like that. This is 0, 1, 2, 3, 4, 5. This is h of k. Then what we have to do is we have to take h of n minus k. So mirror image of this signal. So depends upon our convenience. We can take one sequence constant. This one, this is h of n minus k equal to 0. That is nothing but h of minus k. So this is 0, minus 1, minus 2, and so on. Okay. Then in order to understand clearly, let me redraw this once again. All these combinations for all type of convolution problems. So this should be clear. 0, 1, 2, 3, 4. This is x of k. And x of k is exponentially decreasing function. This is h of k. So let me take u of n constant, h of k constant. So this becomes x of n minus k, then equal to 0. Now this becomes x of minus k. Okay. Now this starting point indicates, and this starting point indicates 0. This is minus 1. Starting point indicates n. And this is n comma k, superimposing both the axes. Now what we have to do is we have to draw the same graph for x of n minus k, n less than 0. That means n will be somewhere here. N will be somewhere here. Somewhere here. This is n. This is n. So now the sequence will start from here. So you keep on coming. Samples are keep on coming. And this is for n less than 0. Now similarly the same graph has to be drawn for another possibility of n greater than 1. This is x of n minus k for greater than 0. That means n will be somewhere here. That is this one. Because it is having infinite number of samples, these samples are keep on coming. Now this is the n value. Now for each and every case you have to combine these two and overlap these two. Final output will be, what is that? So y of n is equal to h of k and x of n minus k. K is equal to minus infinity to plus infinity. So as long as n is less than 0, as long as n is less than 0, that means condition you have to multiply this h of k and h of n minus k. For this case, there is no overlap portion. So samples are here or there. So these are the sample values. So that is multiplied by zeros. So output is 0. So here also, so these values are here and here this is no value here. So output is 0. As long as n is less than 0, output y of n is equal to 0. Output starts only at n equal to 0. At n equal to 0, the sample values, so this sample and this sample will overlap at n equal to 0. So 1 into 1, output will be equal to 1. So this is y of 0 is equal to 1. Then the next value at n equal to 1, n equal to 1, that means this will move one bit right. That means these two samples will overlap these two samples. So in this case, overlap portion between 0 to n. For any other value of n, that means for n greater than 0, output y of n is nothing but summation h of k and x of n minus k. Limits becomes k is equal to 0 to n. Now what is h of k? What is h of k? H of k is a power k u of k. H of k is equal to a power k u of k. And what is u of k? Is 1 for k greater than or equal to 0. So now combining these two equations, of n will be equal to nation. What is x of k value is 1 and this value will be a power k. K is equal to 0 to n. Now this we have to simplify. So whenever you got this equation something like this, there is a formula. So a power k, k equal to n, and this becomes 1 minus a power n plus 1 by 1 minus a. And you remember another equation also, a power k, and k is equal to 0 to infinity. This is nothing but 1 by 1 minus a. You remember these two equations for discrete time convolution cases. So now this equation y of n will be in the form 1 minus a power n plus 1 by 1 minus a. This is for n greater than 0. So we can uh, combine all the values. As long as n is less than 0, output y of n is 0. So final output is 1 minus a power n plus 1 by 1 minus a. So this, if this is multiplied by u of n, so u of n value is 0 for n less than 0 and its value is 1 for n greater than or equal to 0. So final answer y of n is equal to 1 minus a power n plus 1 by 1 minus a into u of n. If you want to plot this waveform and final value, it should go to, as long as n is less than 0, output is 0, value starts at n equal to 0, but n equal to infinity, this value, final value is 1 by 1 minus a. So you will find values like this. Maximum value cannot be more than this. Have a like this. This is 0. Starting from 0 onwards, you will have 1, and final value will be 1 by 1 minus a. So this is n, and this is your final output y of n. With this is the procedure to calculate the convolution between the two steps. So steps involved in convolution. First one is ring or mirror image of the signal. Second one is shifting, multiplication, and fourth one is addition. Depends upon your convenience. You can keep one signal constant, either x of n or h of n. The second signal you have to take the mirror image, and the mirror image signal has to be shifted from minus infinity to plus infinity. Each and every time this has to be shifted, then each and every time this will be multiplied with the constant signal. Then finally you have to add all the signal sample values so to get final output y of n.